He's like, you're recording?
Yeah. All right. So, okay, guys. On this first page, ladies and gents.
Guys, shut up.
Again, I'll take questions on any one of these pages that I had written up on the board. So, are there any questions from 338, which was last night's homework first?
Wait.
338. So again, I'm going to go in order of what I had on the board. 338, 344, 346, and then the last two, 347, 348, we'll do all of them. I know I went over it in class, but I didn't know if there was anybody, maybe not in my class, that had any questions on this page. No, we're good there? All right, moving on then. So that's 338. You didn't have any, that's the one we went over today in class. All right. 344. So 344 is part of tonight's assignment. All right. Okay. Are there any questions from tonight's assignment you'd like me to go over? So this is for my class. Again, this was page 344. Any specific problem or 17? All right. Okay. Guys, this is tutoring. I need you guys to focus because I'm going over stuff. I'm recording this for people that aren't here, so pay attention. All right, on 17. In the diagram shown, explain a method for determining the value of x and y. Then find x and y to the nearest tenth. So there are two properties you have to use on this problem. First, looking at this, we have two chords that intersect. So the first property that we have to use here is the product of the parts of two intersecting chords are equal. Right? The product of the parts of two intersecting chords are equal. Once you do that and find y, then you're able to find x by using Pythagorean theorem. So, second part. Yeah, first part of the question asked how would you solve it. So, that's how you'd solve it. So, to find y, we have 20 times y equals 16 times 16. So, we have 20y. 16 times 16 is 256. Divide 256 by 20. So that's going to give us 12.8, you said? So we have y. Now that we have y, we have two sides of a right triangle. So x is our hypotenuse. So plug in x squared equals 16 squared plus 12.8 squared. Because again, this is now 12.8. 16 squared, we already did that earlier. That's 256. 12.8 squared, I need a calculator for that. Let's see, that's about 150 something. Let's see. 12.8 squared. Oh no, 163.84. Add that with the 256. It's 419.84. And square root both sides. And when you square root it, you get 20.489. Or you could round it off to 20.5.
I have a question.
So
are we ever going to have to like square root it to where like we split it up like we did last time, or are we just going to just straight up square root it now?
Like where you have to rationalize?
Yeah.
Oh, sorry, not rationalize. Simplify a radical?
Yeah.
Yeah. On our homework last night, we had a problem that we could have simplified a radical.
I knew that.
Yeah. Okay. Anything else from this page that you want me to go over? So this was page, again, 344.
All of them.
12.
Yeah,
Can we do 12, 13, 14?
All of them. Well,
I just don't know how to complicate words into.
the other two pages I'm going over, 346 and 347, is a review over everything.
I understand those. I don't know how to put words onto circle.
Oh, so you're having difficulty drawing the images. All right. Well, let me do 12. So on 12, it says the diameter of a circle with center P bisects AB at point X. Points A and B lie on the circle. Classify the triangle formed by points A, X, and P. So, let's see. On here, it says we have a circle with a center at P. The diameter bisects AB. At point X. Points A and B lie on the circle. Classify the triangle formed by AXP. So, this triangle would be a right triangle. And that's the only thing that we know about. We don't know if it's isosceles or scalene or equilateral. Well, it can't be equilateral because it's right. But the one thing that we do know is it's a right triangle because this chord and the diameter must be perpendicular to one another. So the only thing we know about that one is it's a right triangle.
So we can just say it's right triangle. Oh, yes.
Which is fine, but then it asks, so the ends of this part here would be A and B, right?
Yeah.
So then it said the triangle formed by P, X, and A, right?
Oh, so it has to be.
So
that's
then
what I'm confused
you
on.
would-
It's supposed to be drawn by radius, so it has to be like come that way.
Yep, because it said specifically triangle, right? Where was it? Classify the triangle formed by P, X, and A. So I had to draw in that extra piece in order to make a triangle.
Okay.
Yep.
Thank you.
All right. Any others that you want me to do from this side? Because I know all of them. I can do all of them. They're very similar, but let's see. Here, let's do 15. All right, gentlemen. Okay. Again. All right. On 15, so we have the radius of a circular shaped metal gasket is 13 centimeters. A machinist wants to make a straight 10 centimeter cut across the gasket. So, again, it says use geometry software. We're not doing that. We're just drawing. So, here's our circle. It says that the radius is going to be 13 centimeters. He wants to make a straight cut that's going to be 10 centimeters. So let me draw the 10 centimeter cut first. And then the radius that we'd want to draw on here would be the one that we'd want to complete the triangle because it's asking for the distance from the cut to the center. So to complete the triangle, you could draw a radius right here. We know that the radius was 13. We don't know this piece. We do know that half of 10 is 5. So we can use Pythagorean theorem, or you can recognize that this is a triple because we have a 5, blank, 13. What's the missing value? 12. So that one's 12, and that's our answer for 15B. All right. Any other questions on this page? All right. Let's go ahead and go to the next page there, which was 346. On 346, there's only 2 questions I asked you guys to complete. I can go ahead and do both of these. They won't take very long. They have diagrams already drawn with them. Shh, guys. Again, they have diagrams drawn with them, so they're fairly easy. It tells you these two are tangent. Therefore, those two must be congruent. It also tells us that the radius is 5. So I could draw in 5 on either one of these radii. And it tells us that MN is 12. So if that's 12, this is also 12. Things that they want us to solve. They want us to solve a QN, which we just solved for was 12. They also want us to solve PN. If I drew in PN here, well, in order to solve for that, either one of these triangles we could say is a right triangle. And again, it's a 5, 12, 13 triangle. So you can just use your Pythagorean triple in order to solve. If you don't know your triples, plug it into Pythagorean theorem. All right. So again, that's it for that problem. Number 6. Oh, okay.
For the tangents, how do you know that it's an isosceles triangle?
It's not an isosceles triangle, so these two are congruent. There's a property. Let me grab my properties from yesterday. When you have two tangents that are drawn from the same exterior point, they're going to be congruent to the point of tangency. All right. So then, on number 6, we're using that same property for this entire problem, because all of these are tangent lines. These two come from the same exterior point, so to their point of tangency, those two are congruent. From their point of from this exterior point, these two are congruent. From that exterior point, these are congruent.
Oh, from the side of the circle? Oh.
Again, any two tangent segments from the same exterior point to their point of tangency will be congruent. So, in each one of those cases, you have two tangent segments that are congruent. Now, shh, guys. Alright. So now that we know all those parts are congruent, they also told us that AT is 9. AH, which is this entire side, is 13. AD, which is this entire side, is 15. They want us to solve for HD. So that's the part they're asking for. So, knowing those pieces, we can find the rest of them. Because if this whole thing is 13 and this is 9, this piece would then have to be 4. Right? Because 13 minus 9 is 4. These two parts are congruent. So if that's 4, this is 4. If this is 9, this side's 9, because those two are congruent. This entire side is 15, so if this entire side is 15 and that's 9, subtract 15 and 9, you get 6. If this is 6, that's 6. So this missing side is 10 when you add those together. Yes. Am I going to have problems with triples? Yeah. For what? Okay. If you just want to write on your binder, I don't know where it's at. Yes.
For these, do you want us to leave it in like a simplified radical, or do you want us to put a decimal point?
On which one are you looking at?
14.
14?
Because it's asking the diameter, so should we make decimal?
I would probably leave it as a simplified radical since it doesn't have any rounding directions. Yeah. If it doesn't have rounding directions, I'd always go exact value. Yes.
8, 10, 12.
48? Yeah.
48.
Yeah, so I'm going to do all of 347, 348 now. All right. So let's take a look. Shh. Again, this is tomorrow night's homework for my class, for For Miss Oswald, I think you guys have some of this tonight, right? Is it this entire thing? Just select parts?
It's 346 and then 348.
Okay. Did you guys already do 347?
Yeah. Wait,
Okay.
wait, that. Oh.
All right. So just going through this real quick. Shh. On the first part, we're identifying different parts. So it says identify the line tangent to the circle. Well, that would be TR. So the tangent line here is TR. Identify a chord. The chord would be ST.
Would it be TS?
So a tangent line intersects a circle at exactly one point. So this line is intersecting at exactly one point. Which segment is perpendicular to the tangent line?
OT.
OT, because it's a radius. Radius is going to be perpendicular to a tangent. What's the proper name for this segment? Like I just said, it's a radius. Marta claims that it's possible to draw one line tangent to a circle at 2 points on the circle. Is Marta's claim reasonable? No. A tangent line only intersects once. All right. So that's 1 through 4. Over on 5. Oh, not onces?
Wait, you show us. Wait, so it is yes?
Huh? Oh.
He screwed up his grammar. Oh, okay.
Yeah, I added an S at the end of once.
I thought you meant like this. It only is like, is there one point?
Yeah. I don't know how wrong that could be. All right. All right, so now, on number 5. How many chords can you draw to represent the distance between the ends of the blades of a fan? So, on here, this is only the top half of a box fan is shown, right? So, the first question, how many chords can you draw to represent the distance between the ends of the blades of a fan? We have this chord here. We have this chord here. It says the ends of the blades. These would be your blades of fans. Now, you also have another blade that's going to be going down here, right? So you'd have one going down that way and down that way. So far we're at 4. You also have the 2 that would be the diameters going across. The diameters are chords. So you have a total of 6.
6? Oh. I get it.
I don't understand how it's a thing.
Because we have between each of the consecutive blades, I drew a tangent line. So there's 4 between the consecutive blades, right? Then I'm also able to draw the 2 that would connect the ones that were opposite each other, and they are acting like diameters. Diameters are also chords. So you'd have 2 more there. So 4 plus 2 is 6 total. All right, on number 6. In the diagram, CA is tangent to the circle. The radius of the circle P is 8 centimeters. And BC is 9 centimeters. What is AC?
Wait, don't say the answer yet.
Wait.
Because, yeah, let me think about the triples.
Now, there's something that you have to do first.
17.
Because here, this 8 is also where else?
On the other radius.
On the other radius.
But isn't
So this
hypotenuse?
the whole thing, the hypotenuse would be
Okay.
17. So now, is this one a triple?
No.
This isn't a triple?
17.
Should be 8.
8 blank 17?
Wait.
Like I know my triples.
I have a picture of the triples, right?
We can use Pythagorean theorem to figure that out. But I'm pretty sure that's a triple, isn't it?
I don't know. Wait, I got
Isn't that 15? 8, 15, 17? Isn't that a triple? Alright, let's plug it in to make sure. 17 squared equals
minus
8 squared plus
It is.
x squared.
Wow.
17 squared is?
I know the answer.
It's 289. What?
289. 8 squared is?
What's 17 squared?
8 squared is?
Oh, 64.
64.
You need to move your thing down more.
Subtract the 64. That'd be 5. That'd be 225. Square root
C.
of that is 15. Like I said, that is a triple. And 8, 15, 17 is one of our triples.
How are we doing scale factors? What is that?
Hold on.
I like to do 10, 11.
Did I give you one that was not good?
That's right. Yeah.
Well, I'll take a look at it. All right. So that's everything on that page. Let's go to the last page here. Suppose a chord of a circle is 5 centimeters from the center and is 24 centimeters long. Draw the diagram using compasses and straight edges. Again, I told you we're not using compasses and straight edges yet. We'll use them in a couple sections coming up. Is Miss Oswald having you guys use compasses and straight edges yet?
No.
Okay.
So do we just exit the question? Like, you know, exit?
No. You can draw this and do the rest of it.
That's not going to be on the quiz, is it?
Compass and straight edge?
Yeah.
No. That's like a few sections from now.
What?
That's not until after our next test. Alright. So, suppose a chord of a circle is 5 centimeters from the center. So, I'm going to draw the chord. I'm going to draw the distance to the center. That's 5. And it says that this entire thing is 24 long. So then each half of this would be 12. So, yeah, let me draw this in a different color and see if that comes out. So that piece is 12. Guess what we have again? It's our triple again. It's our 5, 12.
Wait, how do you get 12?
Wait.
Five.
Can you slow down just a little bit? Just like 3 notches.
How do you get 12?
It said the whole thing is 24.
So if you bisect
So this distance to it is bisecting it, right? Because the distance to it is going to be perpendicular. So this is now a perpendicular bisector of that chord. So this is going to be 12 and 12, right? So now we have a right triangle when we draw in a radius. So we have 5, 12, 13,
and you have to double it to 26.
and we have to double it to get the entire diameter. So the diameter is 26.
What about C?
All right. So that was our drawing right there. Now, C says, what is the measure of the radius if the circle is dilated by a scale factor of 125%? How do we do that?
No, we don't.
You do.
We don't.
What do you mean you don't? We did scale factors a while back.
Yeah, it's a
How do you find a value if you're given a scale factor?
You times it.
You times it. That's all you're doing. You're multiplying by 125%.
Isn't that 1.25 or am I dumb?
So, yeah, 1.25 would be 125%. That will not be on the quiz, no. All right.
I understand. Do you?
Yeah.
No, you don't.
Totally.
No, you
What? Now, what are we multiplying by 125%?
13.
Only 13, because we're talking about the radius. So 16.25 would be our answer. Again, what we did was 1.25 times 13. That gave us 16.25. All right. It is a dilation. Again, dilation can either be a reduction or an enlargement.
Oh, okay.
Right? 125% is the same as 1.25. It's greater than 1, so it's getting bigger.
I said 0.12.
Oh.
Yeah, only move it 2 decimals there. Yeah. All right. On 8, what part of a circle is considered to be the longest chord? The diameter. The distance between a chord and the center of a circle is 4 centimeters. What's the radius of the circle if the chord measures 16 centimeters? So again, I'm going to draw a diagram. The chord itself is 16. It's 4 centimeters from the center. So then each part would be 8. So I have 4, 8, and this is not a triple, right? 4, 8, no, not a triple. So we're going to have to use Pythagorean theorem.
64 plus.
Are we supposed to draw 64 weird? Whatever.
So 64 is 80 square root. And when you square root 80, 4 square root 5 because, wait.
8 times 10.
Yeah. Because that would be 16. 16 is the biggest perfect square that goes into 80.
Where's that?
So 16 times 5. Square root of 16 is 4. 4 square root 5.
I just feel long way. Yeah, sure. What's 10 and 11? I gotta do 10 and 11 solve. That's the only one that I
Huh?
Here?
Again, when you take a square root, if you're simplifying a radical, here, I'll do this. Let me grab a separate sheet of paper. When you do square root of something that's not a perfect square, in order to simplify the radical, one method is to separate it into the biggest perfect square that goes into it. So the biggest perfect square that goes into 80 is 16. So 16 times what gives you 80? 16 times 5. We can take the square root of 16, which is 4. Can't take the square root of 5, so it just stays under. Again, that's the way I did it. The other method is your factor tree. If you want to do a factor tree, you can find factors that go into 80, so like 10 and 8. 10 could be 5 and 2. 8 could be 2 and 4. 4 would be 2 and 2. So we have 2 2's. Another set of 2 2's. So 2 2's come out. The 5 stays under. Gives you 4 radical 5. Both ways give you the same answer. All right. 10 through 12. All right. All right, on 10. Given the radius of the circle shown is 4, so they already have it labeled. What is the value of x? So x is over here.
Yeah. Okay, can't you do 4 to
Now,
the other side?
any radius is going to be 4.
Wait, don't play.
Right?
Yeah, wait.
So this is 4. This is 4. So this is 4. So then this side is 4. This little piece is 2. This, it tells you, is a perpendicular line, so this one's being bisected. So this is also x. And now, if you just look at this piece, this is 2 chords intersecting. So this entire part of this chord is 6. So we can say 6 times 2 is equal to x times x. So again, the 2 chords, the product, guys, listen. The product of the parts of the 2 chords have to be equal. So this part plus times this part is equal to this part times this part. So 6 times 2 is 12. This is x squared. So then the square root, that'd be 4 times 3 gives you 12. So 2 square root 3 is your answer.
Okay, 11.
All right. 2 tangents are drawn from point A, which is 37 centimeters from the center of the circle. All right, let me draw that first. So we have a circle. We have a point that is 37 centimeters from the center of the circle. So this entire length.
Why did you do that? Why did you
is 37.
You already lost. You know what? Don't even explain. Just he needs to answer. No, he needs to explain.
No, it says two tangents are drawn from that point, right?
Yes. Oh, it's making the triangle.
Right? So, the diameter of the circle is 24. So that means that the radius is what? 12.
So what's the distance?
They want to know what is the length of each tangent. So we just formed right triangles here. So we have the hypotenuse. We need the leg. So we can do Pythagorean theorem. So 37 is our hypotenuse. 12 is one of our sides. We're looking for the other leg. I don't know what 37 squared is. 37 squared is 1,369.
That's a lot.
Wait, what are we doing? Yeah, but minus is 35. I don't know. What is that square root? Minus 144.
That's
What?
1,225.
Oh, 225.
And then the square root of that is 35.
Oh, it's C.
Apparently this is a Pythagorean triple. But would I expect you to know that triple? No.
Yes.
Again, some of the bigger triples I wouldn't expect you to know, because 37 is a prime number.
Yeah.
I would never remember that triple. But I'm sure if I found my list of triples, it's on there.
12, 35, 37.
All right, last one. Number 12. All right, you want me to go back to that one? Sorry. This? Down. Is that good?
Yeah.
So it's just going to be like H275, then DN is going to be
What do you want to talking about?
The next one.
12.
Oh, what were you saying?
I was just saying if I did it right.
Oh,
So I'm going to say, like H2 is 5, then R is 4, and then DN is 8.
yep.
And then you just add them all up, and then you get 34.
Sounds good to me.
34 is the answer?
But what is the theorem again?
I'm so confused. 5 plus 9?
Don't think there's a name to the theorem. The theorem that we're having here is
Explain the theorem.
two tangent segments, right? So there's anytime you have two tangent segments coming from the same exterior point. Let me think of how this is phrased now. If two tangent segments come from the same exterior point, then the length from the exterior point to the point of tangency is congruent. I don't know. I don't think that's how I phrased it the other day. How did I phrase it the other day? Any tangent segments from a common exterior point to their points of tangency on the same circle are congruent.
That means just be exact. 12,
Yeah.
12,
If they come from the same
34,
point, you know that they should be congruent. So,
34, right?
so on number 12, again, each set of tangent segments from the point of tangency to this common exterior point has to be congruent. So these two are congruent. So this is 4. These two are congruent. So this is 5. These two are congruent. So this is 8. So then they want us to figure out the perimeter of the triangle. So we just have to add them all up. So this whole side is 9. This whole side is 13. This whole side is 12. So add them up. 9, 12, 13. So that's, what is that, 21, 34. Oh, thank you.
That was really easy. Can you put the word back up for 346? 346?
346? Yes. All right, let me stop this recording.